Hello, my dear students. Welcome to another online session, and hopefully, all for good and safe in this pandemic city. I'm Dr. Ankur is here to conduct today's session. So, we are going to our remaining session, and I'm telling again if you have any query, please communicate with me through my mail, messenger, mobile, over phone. But this is my humble request to all of you. Please don't be hesitant. Okay, so I'm going to start my today's session. Sterilization control. Okay, here we can also see a picture. Okay, there's a control sterilization control picture. The sterilization control will be there is a thermocouples, bacterial spores, there's a bacterial thermophilus, bacillus stereothermophilus, Brown's tube, autoclave tapes. Next one is the filtration, which is very important. Removal of microbes by passage of a liquid or gas through a film-like material with small pores used to sterilize heat-sensitive material like vaccines, enzymes, antibiotics, and some culture media. So that means we can, if we can summarize the filtration, we can say that filtration is filtration causes the removal of microbes by passing of liquid and or gas. And we are using this sterilization this we are using this for sterilize of vaccine, enzyme, antibiotic, and some culture media. Okay, hopefully we understand. And now we are discussing on the application. It is useful for substance which get damaged by heat to sterilize syrup, sugar, antibiotic solution to obtain bacteria-free filtrate of clinical samples and purification of water. Okay, hopefully you will understand. Now we are discussing about the types of filters. Okay, there we can see there is a picture. There is a many filters here we can see at a glance. Okay, so what are the type are available? Number one is the outward filters, asbestos disc filters, sintered glass filters, membrane filters, air filters, series filters, vacuum and inline filters, pressure filtration, and air filters. Now, the outward filters or candle filters have different grade of porosity, widely used for purification of water. Fluid to be sterilized is forced by suction or pressure. Sterilize scrubbing with stiff brush followed by boiling or autoclaving. Types: ungauged uh, ceramic filters, and now next one is the compressed diatomaceous art filters. Ungauged ceramic filters, example Chamberlain and Dalton filters, are compressed diatomaceous art filters are Bergfield and Mandler filters. Okay, hopefully we are understand. This is the picture all about the candle filters. There, this picture we can see there is a filtrate tube cake space between tubes inlet and the filter cake discharge. Asbestos or filter or SAIDS filter. There is a made up of dust of asbestos, magnesium trisilicate fitted fitted on to a sterile flask through silicone rubber bung fluid to be sterilized is passed through funnel. Example, stage filter, calzone, and sterimate filters. Okay, this is the example of the exhaust filter. And we can see there is a picture of the sterile flask, is a picture of the exhaust filter. There is, we can say, there is a many part we can see in the picture. Number is a sterile flask and the two vacuum pump, filter vessel. Okay, hopefully you will understand this slide. Next one is the center glass filters. Is prepared by size grading powered glass followed by heating. Pore size can be controlled. Membrane filter made up of cellulose nitrate, cellulose diacetate, polycarbonate, and polyester. Diameter from 13 to 293 millimeter with pore 6 from 0.015 to 12 micrometer. 0.22 micrometer pore size is most widely used. It uses water analysis and purification. Number 2, sterilization and sterility testing. Number 3, for preparation sterile solution for parenteral use. Number 4, bacterial count of water. Hopefully we understand. We also see the picture. Our next one is a syringe filter, membrane of 13 to 25 millimeter diameter, is fitted in syringe, vacuum and inline filters. Membrane of 25 to 45 millimeter diameter are used, fitted either with inline holder or vacuum holder, used for sterilization or disinfection of large volume of liquid. Pressure filtration, the large membrane of 100 to 293 millimeter diameter, fitted with Teflon filter, used for production of pure water for labs. Air filters, high efficacy particulate air filter is used for filtration of large volume of air. Effort can remove particles uh, of 0.3 micrometer. Incorporate in laminar airflow. Here means HEPA means high efficiency particular air filter. Okay. Now, the roles of the HEPA filtration, biological flow, safety, curve evidence. We are seeing a picture where is a woman is using for sterilization. Okay, what the part or what are the things we are seeing in this picture? There is a exhaust HEPA filter, blower, supply HEPA filter, light, high velocity air barrier, safety gas, view screen. Radiation. Three type radiation kill microbe. Number one, ionogic radiation. Number one, gamma rays, X-ray, electron beams, or higher energy rays have short wavelengths less than 1 nanometer, damage DNA and inhibit DNA synthesis, used to sterilize pharmaceutical or disposable medical supplies, and plastic syringe, interference line, catheter, gloves that are unable to withstand heat. But is a disadvantage is penetration harm tissue. Human tissue, sorry, may cause genetic mutation in humans. So what is the, we are using the ionizing radiation for the ionizing radiation is a gamma ray, electron beam or higher energy rays, or we are used for the sterilization of the disposable medical supplies, plastic surgery, interventional line, catheter, and gloves. It is very important. Ionizing radiation. Okay. And disadvantage is it is penetrate human tissue and cause genetic mutation. So you have to understand these things and you have to keep in mind. Yes, this is the form of radiation. We can see a picture. There is a 1005 nanometer to 1003 nanometer, 1 nanometer, 1003 nanometer, 1006 nanometer, 1 meter, 1006. There's a many things going on. There we can say see that there is a gamma ray, X-ray, ultraviolet, infrared, microwaves, and radio waves. Visible light, there is a 380 to 400 and 500, 600, 700, 750. This is the wavelength. Okay? This is the all about the form of the radiation. Number two is a non-ionizing radiation, infrared on and ultraviolet light. Wavelength is longer. Bactericidal wavelength is 240 nanometer to 260 nanometer and damages DNA by producing thymine dimer, which cause mutation and used to disinfect operation room, nurseries, and cafeteria. Disadvantage damage the skin, eye, doesn't penetrate paper, glass, and clothes. So what we are using from the non-ionizing radiation, we are non-ionizing radiation is ultraviolet light, infrared or infrared light. We are used to disinfect operation room, nursery, and cafeteria. Okay, and what is the major disadvantage? The major disadvantage is the damage of the skin, eye, and it cannot penetrate paper, glass, and clothes. Hopefully, we are understanding this slide. So thank you very much. Hope all of you are understand everything what I'm discussing in the session and be safe. If you have any query, I'm requesting again, please communicate with me. Okay? Thank you. Thank you very much, my dear students.